Now I want to do a short overview of natural logarithms before we move on to section 23.2. The natural logarithm function appears when we look at exponential reserves, and the simplest form of a function involving natural log is just y equals natural log of x. Here natural log is written as ln, and you probably have a button on your calculator with an ln on it, and that's for taking natural logs of numbers. The natural logarithm is a special function that's related to the number e that we've seen before and the exponential function y equals e to the x. So let's talk about the relationship between e and natural log. You've seen a few variations of the exponential function when we looked at interest compounded continuously and also at population growth. The natural logarithm is actually the inverse of the exponential function, and what that means is that they cancel each other out. So if we take the natural log of the exponential function e to the x, that's just going to give us back x. And similarly, if we put natural log into the exponential function, so if I take e to the power natural log of x, that's also just going to give me x right back. Another way we can picture this relationship, suppose that we know that e to the power a is equal to b. Then we can rewrite that formula as the natural log of b is equal to a. And let's just do some quick work to see why that's true. So you can see it's true by substituting back in and using the fact that these two functions are inverses of each other. So if I look at the natural log of b, I can substitute back in. I said that b is equal to e to the power a. So that gives me the natural log of e to the power a. And then since natural log and the exponential function are inverses, that's just going to give me a right back. Finally, let's just look at the graph of the function y equals the natural log of x, and we'll note a few things about this graph. So the first point is that you cannot take the natural log of a negative number. So if we look at the graph here, you can see that the line, as we get closer to 0, it kind of approaches 0, but it never crosses over the y-axis into this negative x values over here. The second point is that the value of y goes to negative infinity as x gets close to 0. So as x is getting closer and closer and closer to 0, we're just keep going straight down, and you keep getting more negative numbers, and it goes all the way down to negative infinity. As the value of y goes to, positive infinity as x goes to infinity. So you can see that as x is getting bigger here, the natural log, or y, is getting larger also. It's growing very slowly, but in fact, if you do keep going out and x keeps getting bigger and bigger, then y will eventually get to any number that you want to get to. So it does go to infinity in the end. So that's all I wanted to cover. I just wanted to get you a little bit familiarized with what the natural log is, so that you're not just pushing a button on your calculator.